Okay, so we're back for part 2. So we have line symmetry, rotational, and we have point, which is special rotational, specifically 180 degrees. Example 1, we're going to do a few examples. Let's take the alphabet. Now it's printed out in block letters, okay? Part A, what are the only capital letters that do not have line symmetry? Okay, so let's go through each one here, and you're going to ask yourself, can we draw a line to divide this in half? Now I know that A, the way this is printed out, this side is thicker. Let's assume that the thickness is the same though. So for the letter A, we could do a vertical line of symmetry, like that. The left would fold to the right. For the letter B, we could go top to bottom. C, top to bottom. D, top to bottom. E, so these are all horizontal lines of symmetry. F, we could not do. There's no way to draw that to divide it in half. G, no. H, we could actually do this 2 ways. Horizontal, vertical. I, 2 ways. J, no. If I try to divide it horizontally, this part would fold up, but it wouldn't match onto it. K, we could do. L is no. M we could do vertically. N we cannot do. Now this may seem a little tricky, but if I try to divide it by a line here, this would fold onto here, so that would be okay, but this part would have to fold, it would be up here, but this section is down. So that doesn't work. Okay, so far, F, G, J, L, these don't have line symmetry. N does not. O certainly does. Any way you draw a line, it does. P does not. Q does not. There's no way to divide that half and half. R does not. So we have P, Q, R. S does not have line symmetry. There's no way we could divide the S where that would fold onto itself. T is okay. U, V, W would work. X would work in a lot of ways. We could do it diagonally as well. Here's Y. Z does not work. Again, you might think horizontally, but this part of the Z does not fold onto this part. It would fold down here. Okay, so those are the ones that don't work. For line symmetry, which capital letters have rotational? Now that means we can turn it and we'd see the same thing. A does not have rotational because you could try 180, but that would turn it upside down. That's not the same. Rotational would be H. You could turn it 180 degrees, and this would go to here, and this would go to here. I, you could do 180. No. K would not work. No, no. Now, N does not have line symmetry. However, it does have rotational. If we did 180, if we turned it halfway, this would turn to here. This would turn to here, and then this section would turn up. That would rotate onto that section right there. So that would be N. O has rotational. No, no, no. S would rotate 180. This would rotate to here, and down would rotate up. X would have rotational, and then Z would have rotational. And what happens is that all of these would be 180 degrees, so they all have point symmetry. Okay, so we have line symmetry, rotational, and we have point. And that's the end of the first page. Now let's flip it over. We're going to do 2 more examples here at the top on the back of this page. So in number 2, they give you a graph and they give this picture here. That's a hexagon, 6 sides, between which 2 points is a line of symmetry. There are 2 solutions. So first of all, we've got to ask, how would we divide this? How would we draw the lines of symmetry? Well, one way would be to do it vertically, right there. Now you'll notice that if we do that, it intersects the hexagon in two places. So if we connect the points -3, 0 and -3, 4, that would be a line of symmetry. And the equation of that line, they're not asking for it, but we could say x equals -3. That's a vertical line. That's the equation, x equals -3. But we could also draw a line of symmetry horizontally. That's y equals 2. That's a horizontal line. And the 2 points that it intersects would be here. That's actually -6, 2 and 0, 2. Okay, so there's two ways that we could do that. So between these 2 points is a line of symmetry, and between these 2 points is a line of symmetry. All right, and then the last question we'll do here, number 3. Where would you place point E on the coordinate plane? Okay, so down here's the plane, to give pentagon ABCDE line symmetry. What's the equation of the line of symmetry? So they give us 4 points. And we're going to take a 5th point called E, and we need to put it on here somewhere so that when we connect it, we would have something that has line symmetry. Let's connect A to B, B to C, and C to D. And then the question is, where would you put E to make this work? Now, one thing that we can do here is actually, let's turn it sideways, because we're used to looking at a pentagon more like this. So there's nothing wrong with turning your paper. Where could we put a point that would create a symmetric figure? What if we did here? Okay, I'm kind of eyeballing this. If I connect, would that make a symmetric figure? Yeah, I think it would. If we put it here, we could draw the line of symmetry like that, and that looks like it creates 2 equal halves right there. The point A would fold onto D, that B would correspond to C. Point B is 2 spaces from the line of symmetry, so is C, so it's like a reflection. Point D is 1, 2, 3, 4 spaces from the line of reflection, and so is point A. Okay, so that would work right there. So if we put point E here, that would work. Now the equation is y equals, that's -1 where we go through. Now you might have looked at this though and said, wait a minute, I would have put E in a different position. I would have gone to 5, -1, and I would have drawn it like this. And had you done that, you would also be correct. It would be the same line of symmetry. Notice that it's also on y equals -1. It's made this pentagon a little bit taller, but it would still be symmetric. That would be a line of symmetry there. So that would work. Now somebody else, one more of these, may have looked at this and said, but wait a minute, I would have put it right here. And if I draw that, again, I'm creating a symmetric figure, but again, it's the same equation for the line of symmetry. So for this problem here, there are many, many ways. There are infinite ways to do this. You could keep going. You could go like 3.5 or 4.2. You could have said 2.1 or something like that, and you would have created a pentagon with a line of symmetry. Okay, so that's it for the notes. The last 3 problems here are actually for you to go outside. Can you find examples of objects that do have line symmetry, rotational, point symmetry? Okay, so see if you can come up with 2 for each, name them, and then draw a sketch. You don't need to be a great artist for this, but can you see things in the real world that are using symmetry?